Hello and welcome to this episode of All Things Tech, Linux, and so forth. Not what it's called, but you guys get the point. In this episode, we're going to talk about passwords and passphrases. We'll get into why your secret password trick really isn't that clever, how to make passwords using dice, we'll get into how strong dice passwords really are, and of course, at the end of this, we'll also get into when you should use the dice method and when you shouldn't. This is very important. So, to start, passwords versus passphrases. Passphrases are like passwords, but they're longer. And they don't necessarily include crazy characters like pound symbols, exclamation points, squiggly lines, all that jazz. The fact that they're just longer makes them more secure by default. We all need to care more about privacy and improving our computer security habits. This is all in light of the Equifax hack, which, no matter how secure your password is, wouldn't have stopped that, which is kind of infuriating. But this event reminds us just how important this kind of thing really is. Passphrases are the best option. When you encrypt something, the encryption is often only as strong as your passphrase. So, what I'm saying here is, you encrypt a file, you have a key that unlocks it so you can read it again. This key is your password, or in what you should use is passphrase. If your passphrase is weak, people can find it and decrypt it. They're not going to try and decrypt the file by brute force. They're going to try and get to your password first, because it's really unlikely that they'd be able to crack the encryption without your password. If you use a password database like LastPass, or the password saving feature in your web browser, you need to set a strong master passphrase, or all of your efforts to have different passwords on different websites is for naught. With LastPass, it makes your passwords for you, randomly generated. It uses these, a typical password where it's like letters, numbers, and all that jazz, but because every password you have is different, it's much better for security, and you don't have to remember these weird passwords. You can easily change them if a site is compromised. If a site's compromised, then you don't have to worry about other sites getting compromised as well. Edward Snowden wrote this in his email to a journalist, and I quote, "Please confirm that no one has ever had a copy of your private key and that it uses a strong passphrase. Assume your adversary is capable of 1 trillion guesses per second." This is important, and we'll get back to the 1 trillion guesses per second, but keep in mind here, he said, uses a strong passphrase, not a password. In today's segments, we'll talk about the simple way to come up with an easy-to-memorize but very secure passphrase. If your adversary, someone trying to break into your stuff, really is capable of 1 trillion guesses per second, you'll probably do a bad job at coming up with a good passphrase by yourself. Hence, the dice method. Luckily, the usability and security trade-off doesn't have to exist. With the dice method, we can have a good passphrase that doesn't have any ties back to yourself or natural language, which gives the attacker a method of entry. In this segment, we're going to talk about why your password trick probably isn't that clever. People often pick from a passphrase from culture, their favorite lyrics from a song, or a favorite line from a movie or book. Then, they slightly mangle it by changing some capitalization, adding some punctuation, and numbers. Let's use this passphrase. All the world's a stage, where E in the is the letter 3. All the first letters are capitalized, and there's a slash after worlds and before the letter A. Now, I was probably not the first person to use this slightly mangled passphrase that I generated from the classic Shakespeare quote, and attackers know this. There's a lot of us out there making a lot of passwords. Chances are that's already been used. The reason this Shakespeare quote is a terrible passphrase isn't because it's has these interesting characters in it, but it's because it lacks what is called entropy. Entropy in passphrases can be considered as a randomness. And us humans are really bad at randomness. Because we humans love patterns. We love making patterns. We are incapable of doing anything that is truly a random fashion. But that's where things come in. And here, we'll get into that in a little bit. What if you don't use a quote, but instead make up a phrase off the top of your head? This sounds like it would work, right? Like, okay, it's not anywhere in existence, this should be fine. This passphrase will still be far from random, because language is predictable. Think about this, right? Our brains love to use idioms and rules of grammars, whether we will choose to or not, and this both reduces randomness, this both decreases our entropy. In order to use a good passphrase, it can't have any idioms, it can't have any rules of grammar. So if we think about when we're making passwords, let's say we're not going to use all the worlds of stage with those weird letters in there and whatnot, but instead we choose to pick some words that have nothing to do with us. Let's say we pick the words, I'm going to say tricycle flower bed, right? Let's say that those two words are going to be my passphrase. Even though it sounds random to me and my brain, and maybe to you as well, there is still grammar mixed in this, whether I choose to or not. And I just thought of that. Like, you're like, okay, that must be random, but it really isn't. Or how about sequence wonder? This could be used in a sentence. That's not something, even though it seems random. I picked two random words that I just looked at from far here in the room. They fit together. It sounds grammatically correct or close enough, right? What if we do like railroad settlement? Well, that's obviously could be something in reality. So this is the problem with making passphrases by yourself without using the dice method, which we're going to get into next. Our brains are consistently trying to adhere patterns. No matter how hard you try, your brain has biases, and it's going to introduce these idioms and rules of grammar, and it's going to reduce the entropy. The lower the entropy, the better the chance someone has of cracking your password. The better chance you have of those words being on a list that people use to crack passwords. And this is where we need a better system. We need to take the human element out of it and let randomness in nature take over. So, how do we make a secure passphrase? Well, as I alluded to in previous segments here, we use dice, or a single die, whichever you prefer. If you have more dice, it would go faster. So enter the Diceware word list. You can find this list just by searching on the internet for Diceware word list, and you'll find a PDF of 7,776 English words, which turns out to be 37 pages of PDF. If you want to print that out, more power to you. Next to each word, there is a 5-digit number. Each of these digits range between 1 and 6. There's also another word list that the EFF made with the same amount of words, and they claim that their list contains words better suited for typing. This list can be found by searching EFF large word list, and you'll find a .txt file that lists them all. It's quite enormous. So grab one of these word lists, and then grab a few 6-sided dice. Yes, you need actual physical dice. This is a very important, the physical dice part. Then roll them until you have 5 numbers. So if you have 1 die, well then you have to roll it 5 times for your first number to find your first word in your phrase. If you have 5 dice, then roll once. 5 dice is gonna be optimal for this situation, but doesn't matter. It all works. This will match a word in the list. Like I said, this gives you your first passphrase. And then you repeat. And you do this as many times as you want your passphrase long. What you're doing here by rolling the dice is generating true randomness that is only given to us by nature. This eliminates the human brain. So what you would end up with is something like this, and I'm going to preface this by saying don't use this 7-word passphrase that I randomly generated, because if you do, well, now it's on the internet and people can use it, so be smart. But when you roll your die, if you have 5 dice, you roll it once, and you roll them 7 times, and you get 7 different words. It'll sound like this: acorn, overstate, Ferris, outlet, mosaic, laurel, hardy. Those words are truly random. The longer the passphrase, the more secure it will be. So think about this. If you have 1 passphrase, or 1 word in your passphrase, well then, it's really gonna take a little bit to crack it. And in the next segment, we'll get into these numbers exactly to show you that going from one word to 2 words increases, but going from 2 words to 3 words is even a bigger increase, and going from 5 words to 7 words is astronomical. I would strongly recommend using a 7-word passphrase such as acorn, overstate, Ferris, outlet, mosaic, laurel, hardy for something like your password manager's master password. Something you type in enough to remember it, but not so often that it's exposed everywhere. You can also use something this strong for encrypting things that you need encrypted, such as your bank statements, your medical statements, anything that's very personal that you don't want in the hands of an attacker. This is when you use these strong passwords, and when not to use these strong passwords, we'll talk about that too here in a segment in the future here. But this is how you make a truly random passphrase. It's really random and hard to crack passphrase. More words are better, more dice rolls are better, but we need the dice, because the dice allows nature to take over and be random. Humans can't be random. It's impossible. I saw a video where they had a person switching a light on and off, and a person flipping a coin to switch a light on and off. It was obvious to me which one was the human and which one was the coin flip. Not sure why, but it was. So keep that in mind. Attackers understand this. You need to use a strong passphrase, and use the dice method to come up with the strongest passphrase possible. Now let's discuss how strong these dice-generated passphrases really are. The strength of the dice-generated passphrase solely depends on the number of words it contains. If we choose 1 word off the list, an attacker has a 1 in 7,776 chance of guessing the word on the first try. This sounds big, right? This sounds big, but when it comes to computers trying trillions of guesses per second, that's correct. In under a second. That simple. It'll take an attacker at least 1 try, at most 7,776, but the average tends to be 3,888 tries, so it's even less with 1,000 guesses per second, as Edward Snowden said we should assume an attacker can use. It would actually only really take 3,888, which is so far below a trillion, I don't even know how fast that would be. But what if we roll our dice twice? Well, roll our die twice and roll 2 dice. To get 2 words, that's what I'm saying. To get 2 words, roll the dice enough times to get 2 words. There we go. With 2 words, there are 77,762, or 60 million different potential passphrases. Keep this in mind. I think I had the number wrong here on the list. However, the first number, that is, we're doubling the 7,000, so it wouldn't be 77,000. That doesn't make any sense. It'd be like, close to 15,000 different words we can use. But if you have all of those in combination, you can put any one before any one and vice versa. You get over 60 million. 60,466,176 different potential passphrases. That's a lot bigger than 778. Or 776, I'm sorry. This is still less than a trillion, but much closer. It'll still be cracked in under a second, but we're doing better. On average, a 2-word dice phrase would be guessed after about the first 30 million tries. So, that's still a lot less than a trillion, but like I said, we're doing better. See how this goes, right? It doesn't double. It magnifies. It goes from an average of, if you have one word with your dice, it goes from an average of 3,888 to an average of 30 million. That's epic. But what if we use a 5-word passphrase? Your password could be guessed after an average of 14 quintillion tries. 1 word, 3,888. 2 words, 30 million tries. 5 words, 14 quintillion. I don't even know what a quintillion is, but that's a big number. If an attacker knows that you're even using a word list, and you're using 7 words, and which word list you're using at that point, because there's more than one now, they can pick 7 random words from the word list to guess. And they have computers do this for them automatically. That gives them a 1.719 octillion chance that they'll pick your passphrase on each attempt to crack the phrase. That's crazy. That's crazy. An octillion. That's bigger than a quintillion. That's bigger than a sextillion, a septillion. That thing's enormous. At 1 trillion guesses per second, as per Edward Snowden's warning, it would take an average of 27 million years to guess a 7-word passphrase using the dice method. And with this dice method, we get a passphrase like Acorn, Overstate, Ferris, Outlet, Mosaic, Laurel, Hardy. It's easier to memorize than something with capital letters and dollar signs and exclamation points. And it's harder to crack. Very important. So finally, in today's episode, let's talk about when to use the dice method, because clearly, typing 7 random words that you memorized every time you want to enter a website is kind of unrealistic. So dice-generated passphrases are great for when you're typing them into your computer to decrypt or encrypt something locally, such as a file like your taxes and whatnot, but you don't really need them for logging into a website or other internet-related things. And this is because attackers will never be able to run a trillion guesses per second, when each guess has to be sent to a server on the internet, and then sent back to them with the answer, such as a site's login page like Facebook. They are much more likely to grab your passphrase as soon as you log in, by imitating and pretending to be the site's login page, and then you could have the longest passphrase, the longest and strongest in existence, and it will not protect you, because they know what it is. It's in plain text. So, for logging into websites, I mentioned this earlier, use something like LastPass or KeePassX. KeePass is spelled KeePassX, and LastPass is spelled like LastPass. And then take your strong take one of your you should have more than one of these strong passphrases. Don't use the same strong passphrase for everything. Use one strong passphrase for your LastPass password manager, or whatever one you use. Use a different one for encrypting your taxes, and one for encrypting your medical bills, or whatever. Like, don't use the same one every time. This is good for your master password because they have to guess that, and they have to keep guessing, and keep guessing, and keep guessing. They might know they'll probably know your email address. They'll have a LastPass installed, and then they'll just start trying to guess random passwords. It's a little bit different with LastPass because it still has to communicate with a server on the internet, so it wouldn't necessarily be as advantageous to use 7 words. You could still, I use I wear a very strong passphrase for my LastPass account, but something like KeePassX, which is on your computer and not on the cloud, they could run 1 trillion guesses per second and try and crack your stuff. It's very possible. So use the strong passphrases for these things. Then use the password manager to generate and store a different random password for each site you log into. This is absolutely critical for your security on the internet when it comes to your information on somebody's website. Use a different password. There are too many people out there using the same password over and over again. You can go onto the internet, you can search for top 100 most used passwords, and you can see what they are. They're most used. Like, the word password is probably, I think it used to be the most used, I don't know if it still is, but it's one of the most used passwords. It's in the top 10. This is crucial for you to use a different password. And don't use a password that's on the top 100. Don't use a password that's on the top 1,000 or the top million. Use the password that's randomly generated from one of these password managing accounts for logging into websites. I also want to point out that KeePassX is really cool because it's free, as in, no money. It's open source, so anyone can check the code and make sure that it actually is secure, and it's cross-platform. So you can use it on Windows, Microsoft? What is Microsoft? Windows, Mac OS, and Linux. They also have versions of it for your phones, such as Android and iOS. I believe iOS. I know for Android there's a version of it for Android. And what else is cool about this is there's no cloud storage. So I use LastPass, and it is cloud storage, but I only use it because they encrypt all of my information. So if someone would somehow break into their database, all they would see is encrypted information. They did get hacked once, and the person all they took were the encrypted passwords. So what you do is then you just make a new password with your dice phrase and change your LastPass passphrase, and now you're still secure. All of your stuff is secure on their servers by encryption. I trust their stuff for now until it breaks, and then I'll go something else. But if you're really worried, use KeePassX on your computer locally and use that. It's probably the best way to do it. If you want to be super secure, put it on a computer that doesn't have internet access, and then you're 100% secure. Because once you're on the internet, it's not secure. Thanks for listening, guys. I hope you enjoyed it. If you have any questions, please call in with your questions, and I'll be happy to answer them. Until next time, thanks for listening.
The podcast you just heard was recorded with Anchor. If you want to make your own, download the Android or iOS app completely free from anchor.fm/podcast. That's anchor.fm/podcast.